All right, sir. So you can take over, and that's the
Thanks.
meeting, sir.
So, please, can you confirm if you can see my screen?
Yes, sir.
Okay. Right. Good morning, everyone, once again. My name is Amir, and I work as an AI specialist, right, in one of the telco companies in Nigeria. And I will be your host. I will be walking you through, what is all this craze about AI, what is AI, what is ML, and what it's capable of achieving. And we would actually do something. We'll walk through a simple model to actually see how it works, right? So basically, it's basically like what the slide says. We are trying to, or we are going to understand AI and machine learning without the jargon, right? So this aims to introduce you into the world of AI, right? So we can move on. So what is AI itself? You can look at AI as a system that tries to be intelligent. That means that it tries not to depend on to depend on human input as less as possible. It tries not to depend on humans as much, right? It tries to do things as autonomous as possible. Now, when you talk about AI systems, you can look at Netflix. You wonder, how does Netflix know the kind of movies I'm interested in? Or you can even take a look at Instagram, where you know your explore page is definitely different from another person's explore page. So there's an AI system embedded that tries to learn your habits based on what you've been watching or viewing, and uses that to recommend things that share similar that are similar. Now you can also look at unlocking your phone, especially iPhone. iPhone was they were the breakthrough. Sorry, Apple was the breakthrough company when it came to facial recognition in recent years, right? They were successful with their iPhone X, So that is also AI. It forms like a 3D print of your face and tries to unlock it irrespective of the positioning of your face, right? And then you have the popular one, which is the email spam, right? So it tries to look at the emails you get and look for words that are not quite appropriate and labels them as spam or no spam. So these are some of the things that AI is capable of doing on a high level. So when you talk about AI, we can't leave out machine learning. So look at AI as the umbrella, right? And you have machine learning under it. So machine learning focuses on using data, historic data. It learns from that and uses it to make assumption when it is exposed to new data that it has not seen before. So take a look at this. Look at machine learning, a new system as a baby. A baby learns as it matures, right? Sometimes that's why you say some children that are 16 are more mature than people that are 19, because it's not just about the age, it's about the experience. Someone that is 16 might have experienced or been exposed to different form of environment, different form of data that the 19-year-old human has not seen yet. So you don't expect them to approach life, or when they encounter new challenges, you don't expect them to approach it the same way. So that's similar to what we are doing here. Machine learning looks at data. The more experience it has, the more it is able to make sound judgments when it is exposed to situations or data that it hasn't seen before, right? So under machine learning, we have the deep learning. Deep learning is a subset of machine learning. How does it differ from the traditional machine learning? So deep learning tries to mimic the human brains. If we had a doctor in the house, we know that the brains are made up of neurons, and that is what deep learning tries to do, right? So you expect that a deep learning algorithm or a deep learning model would, in a lot of cases, should likely outperform a traditional machine learning model because it is learning deeply, right? Then under deep learning, we have different types: artificial neural networks, which is the most popular deep learning algorithm. You have CNN and all of that. So I think we can move on. And yes, we don't have to wait for me to finish the presentation. You can ask questions, so you don't forget them. As I present along, you can ask questions if you have any. So the three popular types of, machine learning, and yes, for the sake of this course, we will be focusing on machine learning. So for machine learning, we have three, which is the three types or three ways, in which a machine can learn. You have the supervised learning, you you have the unsupervised learning, and you have the reinforcement learning. What's the difference between these three? Supervised learning, basically, I want to predict, I want a system to predict if a fruit is an apple or an orange. In supervised learning, you would feed in and train the machine with a data on apple and tell it that, look at this color, look at this shape, look at this height, this is an apple. Give it the answer. Look at this. So when it sees an apple somewhere else, it might not fit exactly, the way an apple looks like, but if it has some characteristics of an apple, it should be able to tell you that this is an apple, right? Then you have unsupervised learning. Unsupervised learning, there's nothing like this is an apple or this is an orange, or you don't tell it what it is. You only give it a bunch of data and you tell it that try to find pattern between them. For example, you give it a mixture of data of different races of human beings. For example, maybe data contains race, white humans, Asians, and maybe black. And you didn't explicitly state in the data that, look at all of these things, target as white, look at that, target as black. So the model will try to find a form of pattern and classify it. No, classify is not the word. Cluster it based on these patterns that, okay, looking at all of this group of clusters or this group of people should be white. This group of people, and this is exactly where we are trying to master. If we can master, the part where, without being given labels, without being told that this is the target, this is something, you should be able to find patterns, and that is what, if machines can actually achieve that by 100%, then we would have a crazy breakthrough in AI. Then we have reinforcement learning. So look at reinforcement learning as um, a self-driven car. It uses its environment, learns from its mistakes, and corrects itself. That's all you need to know about reinforcement learning for now. But if you want more explanation, you can always ask me. So for the sake of this, we'll be focusing on supervised learning. Now, like I explained before, you have input data. This is an orange, this is an apple. Train it, you've told it what it is.
Hello.
Yes, I'm with you.
Sorry for cutting you short. I
Of
just
course.
want to know if the students are following.
Right.
Hello, everyone. Please, if you are here and you're following, just signify with an emoji, please. Or Abiodun and one other person. Okay. All right. So they are here. You
All
can
right.
continue, sir.
Thank you. Something just even struck me before we move on to supervised learning. It should be noted that machine learning didn't just start, recently. I'm not even talking 2005. Machine learning has started since 1950. Where you talk about the first one of the first models that was built to play chess on its own, right? And I think sometime in the 1970s, it actually was it 1970s or the 80s, one of that, we can do the research after this. It actually beat the world best chess players at then. I think it was Go something. Anyway, the point is machine learning has actually been there. In fact, neural networks, as at that time they called it perceptron, right? It had already existed since 1970. So you ask me that if all of these things have existed, why was everything everywhere so cold until recently that we started hearing the machine learning craze? Well, to answer your question, I just told you earlier that machine learning relies on a huge volume of data. And as at that time, we're limited by the volume of data. In fact, there's an argument that states that 99% of the current data we have currently was only generated about 2 years ago. So we're limited by data. We're also limited by the capacity of the computers we had as at then to process all of this. So that was why it went low until recently with the big boom of social media and data and all of that. So back to what we are saying. Input layer, it tells you this is an apple, this is an orange. Look at the characteristics of what makes an apple and an orange. Train on it and use it to identify that this is an apple, this is an orange. As you can see here, input label data. The data is labeled. You tell it what it is. Then when the model is trained, you now give it an input, a fresh apple. It doesn't necessarily have to look exactly like this. It just needs to share some form of characteristics. Then the trained model looks at it and makes an assumption, and this is the output. It tells you, oh, this is an apple. So here is the data. The output is here is the correct answer. So it basically learns how to match the input to the output. That's what supervised is all about. So an everyday example of supervised learning could be, or maybe you want to buy a house, right? And you want to, before you even, or you want to even know you are getting a good deal without, speaking, you can actually use your algorithm to do it. You know that, okay, 200 square foot meter is 60 million naira, and so on and so forth. But what you want to buy is 250 square meter, which you don't know. You can easily do a machine learning model to help you predict. So 250 square meter could be 110 million according to the machine, right? This is an example of supervised learning because you know what the price of a 200 square feet meter is, you know what the price of it can be, and so on and so forth. So you know the target. So it looks at this feature, and tries to make an output, an assumption, right? So what are the common, of course, there are tools we use to do stuff in machine learning, especially supervised machine learning. We have stuff like linear regression. We have decision trees, random forest, support vector machines, and neural networks. So don't worry about these things. These are just tools, like I said, right? You don't have to be a guru, to use these tools, right? So linear regression tries to it's one of the easiest or most straightforward part of regression. So it tries to find, for any of us that are good at math, it tries to find the line of best fit. If one of us are in sciences, we did maybe physics in 100 level, we know stuff about slope and all of those things. So when we draw a slope, it tries to find the line of best fit, right? That is what a linear regression does. It tries to make sure that it predicts as accurately as possible in a linear way, a straight line. Now, decision trees is just your flow chart. Should I do this? Should I not do this? Given all of these features or constraints. Should I make this decision? Should I not make this decision? Random forest is a combination of two or more decision trees together. Just like it says, a forest is a combination of trees, right? So random forest tries to improve on the performance of trees because it uses more than one tree. And then support vector machines beyond the scope of this work, but we can discuss this further if you have interest. Neural networks, like I mentioned earlier, tries to mimic the human brain. It thinks deep. Think about ChatGPT. It uses neural networks. It is sometimes when you prompt it or when you ask it questions, you see stuff like thinking, right? It tries to mimic, it tries to think and gives you better answers. So why does it matter to you as a person? Everyone in this day and age, regardless of whether you're a techie or not, you should know what machine learning is and how it can, supercharge your business. It's not just about writing codes, it has nothing to do with that. In fact, as a professional data scientist or a professional ML personnel, or even data analysts, because data analysts sometimes find themselves using linear regressions and other algorithms like that. You should understand that this is the problem my business is facing. This is the way I can use AI to supercharge and get ahead of the competition, right? I can predict my customers' behavior before they even know what hits them. I can tell my customers this is what you need, and they start asking themselves that, how the hell did you know? I didn't even know I needed this, but it looks interesting. So it puts you ahead of the competition. Every company that invests heavily in AI is indirectly making themselves ahead of the competition automatically. Detect fraud, save you a lot of money, improve services by improving automation, saves your time. In this day and age, if you want to put a PowerPoint together and you sit down and want to start from the beginning, doing it all by yourself, trust me, you would not only waste your time, you will not be as efficient as someone that uses some form of language models to do it. The point is, don't rely completely on them, but use them to save your time and build on it. You can make smarter decisions with AI because you have insights, you have future knowledge, and of course, you don't need to be a coding expert, just understand how it supports strategy. Now, let me I think I already mentioned this, but just to give you more context. For reinforcement learning, a quick peek into unsupervised and reinforcement learning. For reinforcement learning, you have a dog, right? A dog is, in this case, the dog is the AI agent or the AI model, but we are just using dog. So a dog is, you tell a dog to sit, it sits. You now tell it that walk, it walks. You reward it. But if you tell it to sit, it sits, and tells it to walk, it does not walk, you penalize it, you punish it. So it knows that I will not do that again next time. And the loop continues. That is how reinforcement learning works. Now, for unsupervised learning, you see all of these clusters. Well, I want to know the income of people by their profession, right? I don't know how the students look like from my data. I don't know anything. All I know is that I have data on students. I didn't explicitly write it anywhere in my data that this is a student, this is a soccer mom, this is a retiree. So my goal is that as an unsupervised machine learning, I want you to be able to look at all this data and look at the characteristics and cluster all the students together in one place. The soccer moms in one place, the executives in one place, the retirees in one place. What this will help me with is, if I am doing customer targeting, I know that, and I want to come up with initiatives or strategies, I know that I am targeting the right, set of people. For example, I am not sending, for example, reading materials to soccer moms. In fact, I'm hurting my business that way. Or I'm not sending kids stuff to students, because a student, all things being equal, is not expected to have kids, you know. So the point is, if by effectively grouping people based on, what they are, you can effectively drive strategy, targeting, do, pushing the right ads, advertisements to the right audiences, right? So these are some of the power of AI generally. Now, the key takeaways from this: AI makes machines smarter. What I mean is that the old way of software development, where you write logic, if this is this, do this, else do that, or do this, do that. How many cases do you want to write? You cannot write all the possibilities in this world, right? And that is where AI comes in, because it doesn't expect you to write if else, or if this is this, do this, else do that. It learns from data. So it can make, so even if it sees something that it has not seen before, that is not in the code base, it can infer that, okay, based on my experiences, I think this is this. Thinks like a human being and not a robot. That is the goal. Now, machine learning helps machine learn from data. We know that. Supervised learning is the most used and easiest to grasp. You don't need to be a programmer or a hardcore programmer. Just know what's possible with AI. Now, this is where, we come in. Let's chat. What surprised you? What is new to you? What is not so new to you? What tool would you like to understand more? Where do you see AI, helping you as a team member, team player, or even a business owner? Or any other questions you might have, the floor is open. Thank you.
All right. Thank you, sir. Hello.
Yes, Joy, I can hear you.
All right. Thank you very much for the introduction so far. And I think a student asked a question: how do we describe AI? Though I've tried to answer, but my own understanding. How do
How
we
do we
describe AI?
how do we describe AI?
Predictive or generative or a combination of both?
Thank you. Good question. So AI is a combination of both. So to give you more context, pre-2020, we looked at AI as predictive. So predictive in the sense that there is data, right? There is data. Now, based on what we've learned from that data, we want to predict what will happen in the future, just like stock prices and all of that. Now, generative is, you won't particularly consider, for generative, you won't particularly consider it as machine learning anymore. It's more of AI. So what generative does is that it looks at your data and tries to create something new from your data. So what this means is that predictive is, okay, I have so words. My name is something. Predictive, what is the likely thing you want to say? Okay, my name is Joy, or my name is Amir. But generative means, can you create a simple code for me to build, or can you create a code for me to build a simple website? See, now it's generating stuff. Or create a code for me to build website for my business. I'm into logistics. It generates from scratch that way, right? So that is the difference. So to answer your question, AI is a combination of both predictive and generative. Thank you for that question. While machine learning focuses more on the predictive. I hope that provides clarity.
Yes, to me, but Lulu, please, you can drop your answer in the message box, please, chat box. Hope you are cleared on that. All right, sir, you can continue. Thank you.
Okay. So, should we take a break before going into the codes on how we built our first model, or we should go ahead?
You can go ahead, sir. We
Okay.
take break by 11. That's when we
By
normally take
11.
break.
Okay. All right. So let's go ahead. I think so. I would, if we have the time, I would like us to follow along or code along. As you know, it would be very beneficial if we can code along. So, if anyone wants to set up their work desk before we start, I can wait till we're all good. So if we are setting up our work desk, we can signify. So I would not ask to wait for you. We are using Google Colab, right? You can just go on Google, just type Google Colab. This is it here. Google Colab. You click on it. Most likely you'll be signed in, because if you have a Gmail account, you can use it. I think there's a message in the chat. I heard the sound now. Let me try to check.
No, don't worry, sir. I'm the one that's dropping message.
All right. Right. So, if we are following along, like I said, let's do it on Google Colab on our search engine.
Hello, sir. Hello, instructor.
Um, Lolu, I hope I pronounced that correctly. So your question is it safe to say ML is more focused on creating algorithms? Well, in both cases, you are creating algorithms. ML is focused on using your past data to predict what will happen. So you are using, say, Cold Stone employed you, for example, to as a data scientist. Now they have a bunch of data on how people have been. Right, the line is breaking. Can you hear me?
We can hear you now.
Right. So I was saying, the question about someone was asking, so is it safe to say ML is more focused on creating algorithms? Now, to answer that question, say Coldstone were to employ you, right, to be their data scientist, they give you data. Your data contains the sales of their the sales of ice cream in the last 4 years, 5 years, 6 years. And now they're telling you that we notice that sales are going down. Can you build some form of model to help us predict what the sales will be in the next 3 months so that we can plan ahead? And now from your AI modeling, you realize that some particular time of the year, there is actually low sales. It will help you say that, okay, at this time of the year, expect that there will be a drop in sales. So machine learning looks at data and predicts from it what will happen in future. Generative AI looks at data and generates something new that doesn't necessarily look like what it has. It's not predicting, it is generating. Look at like ChatGPT is a generative AI. You don't tell ChatGPT to predict something. It can do that, but its power, where it shines, is okay, help me. I have this assignment, help me do it. Or I have this, and that is why you would always see things like thinking, because it's not predicting, it's generating. So it's not telling you what will happen in the future, it's creating new content for you. Help me put my CV together, or help me write an essay, a cover letter, stuff like that. You are generating, you're not predicting. But ML predicts what will happen. That's the difference between them. Exactly, Lulu. That's it.
Okay, sir. Thank you for answering this question. So, questions are normally answered every 30 minutes, so that we won't disrupt the
Love the
class.
class. Right, right.
Alright, so the question
Let
is,
me try to present my screen again. Okay, can you see my screen? Can you see my screen? Hello?
yes,
Hello?
I can see it.
Yes. Okay. Yeah, thanks. So we click on new notebook. And when you click on new notebook, this should come up. I hope we're all here. It will be nice, like I said, it will be nice to code along so we can have a feel of what we are doing. The first thing is to import the file. Oh, right. Do they have access to this file? To the file we are going to be using, this data set. Joe, do they have access to it?
Yes, sir. I already dropped it in
Right.
group.
Thank you. Thank you. If you have access to this file and you've saved it to your computer, this